FLA set out to develop some new algorithms to enable small unmanned airplanes to fly in complex, low, close to the ground environments with only onboard resources, so onboard sensors and onboard computing, and limited data a priori. So we go into an unknown environment that is cluttered with all kinds of obstacles, and we don't have the benefit of GPS or an RF link. How can we fly in that environment? That was essentially the challenge that FLA undertook. So in phase 2, I had each team focus on pushing the state of the art within their strength. We had one team focus on flying very fast in a natural environment, trying to avoid obstacles at the maximum speed the vehicle could do. The second environment I looked at was an urban setting. And in this case, I was focused on comprehending the scene both from a semantic and a dimensional perspective. So understanding that we were flying over a street and there are cars, buildings, roads, and then looking at building a map of that environment, not necessarily a dimensional map, but more like a semantic map, where we have the streets and then we say there are 3 cars in that street, for example. And the last team focused on flying in very confined spaces, so going through very small apertures and going also in more of a 3D kind of environment. So you had the ability to go through a second floor window, visit rooms that are open, find a staircase, go down and exit the building, for example. FLA is an applied research program. We're really developing the capabilities. However, we always keep an eye on how would we use this in a military context. One of the examples that I like to give of the ability to use a small robot, whether it's an aerial robot, a drone, a UAV, or a ground robot, they can become essentially small scouts. So when we send that vehicle, it will explore the space rapidly and then come back with all the data telling you whether it's safe to go across that city block. There are many other applications to this technology. It is not just about helping soldiers cross safely a city block, although that's a worthy goal in and of itself. There are many places where we want to go and it's not safe for humans. Not necessarily because people are going to shoot at us, but sometimes you have a structure that is no longer safe or that is not known to be safe. So after a major catastrophe, an earthquake, a tornado, how do you know the building is structurally sound? And so FLA has the ability to go and fly in these unknown environments without any connectivity. Why autonomy, right? I mean, we see the videos online of these incredible pilots doing, very fast racing, first-person view racing, and they're amazing. And eventually I think we'll beat them, but we're not there yet. However, not everybody is that good. I mean, we don't want to deploy a world-class FPV racer with every search and rescue team, whereas we can deploy our software to every search and rescue team.